Hi everyone, welcome back to my YouTube channel Chemistry with Sumitpramar. In this video, we are going to solve next 5 questions of the same past paper year 2022. Let's look at question number 11, which says when K2MnO4 is dissolved in water, the following reaction occurs. Right? What could be the values of A and C in this balanced equation, right? Okay, so we can solve this question by multiple methods. One of the methods could be algebraic equation, right? Algebraic method, and the other one could be half equation method or maybe oxidation number method. We will be solving this one with the help of half equation method, right? So before we do that, let's find out the oxidation number of each of these species, each of these elements, right? I can see that in the first part, let me write down the equation. MnO4 2 minus plus H2O gives MnO4 minus plus MnO2 plus OH minus. Okay, so I can see that the oxidation number of manganese in this case, you can calculate that considering that Mn has an oxidation number of X and each oxygen atom will have an oxidation number of -2, so 4 plus 4 times -2 is equal to the sum total, is equal to the total charge, which is 2 minus, right? So X minus 8 is equal to -2, X is equal to plus 8 minus 2, X is equal to plus 6. The oxidation number of manganese here is plus 6. Similarly, you can find out the oxidation number of manganese here, and it comes out to be 4 to the 8, so minus 1, so plus 7, and here it will be plus 4, right? So I can see that manganese is getting oxidized as well as it is getting reduced. So this is which type of reaction? This is disproportionation type of reaction, right? So I can write down the two half equations separately. One can be MnO4 2 minus gives MnO4 minus, and the other one could be MnO4 2 minus gives MnO2, right? The oxidation number is plus 6 and this is plus 7. In this case, we can see that first equation, the manganese is losing one electron, so I can write down plus E minus. In the second one, I can see that the oxidation number of manganese here is plus 6 and it is plus 4, so I can see that it is gaining 2 electrons, so I can write down plus 2 electrons. Now we can balance the number of electrons. If we multiply this one with 2, first equation by 2, this will be 2, this will be 2, this will be 2, right? If I balance these, I can say that this 2 electron will be cancelled and will be left with 2 MnO4 minus and MnO4 2 minus, so that is 3 MnO4 2 minus. It gives 2 MnO4 minus, 2 MnO4 minus plus MnO2. Now we can balance the charges. On the reactant side, I can see that there is 3 times 2, that is 3 to the 6 minus, right? On the product side, I can see that this is 2 times -1 minus 2, right? 2 minus. We need to balance the total charges, right? And for that, we can see that from the equation we can add OH minus to balance these charges. So 6 on this side, 2 on this side, that means we need 4 OH minus. Now 4 minus 4 and minus 2 will give you 6. So the charges are balanced. Now let's look at the atoms. There are 3 4s 12 oxygen on this side is 4 2s 8 and 8 plus 2 10, 10 plus 4 14, right? On this side it is 14, on this side it is 12. So I can add 2 water molecules. You can see that the hydrogen 2 to the 4, that has also been balanced, and all the species are balanced. So this is the required balance equation. And the question is, what is the value of A and C in this one? So A is the coefficient of MnO4 2 minus, which is 3, and C is the coefficient of C is the coefficient of MnO4 minus, which is 2. So the correct answer should be 3 comma 2. C is the correct answer. Now let's look at question number 12. We have to write the expression for Kp for this reaction. We know that Kp is equal to partial pressure of product raised to the power of their stoichiometric coefficient. Here the stoichiometric coefficient of product is 1 upon partial pressure of reactants raised to the power of their stoichiometric coefficient. So 2 is the stoichiometric coefficient for hydrogen and 1 is the stoichiometric coefficient of carbon monoxide, right? So we'll be using this. So Kp should be equal to partial pressure of product is what? CH3OH raised to the power of the stoichiometric coefficient, which is 1. So raised to the power 1, we don't need to write that, and upon partial pressure of reactants is what? Hydrogen raised to the power of the stoichiometric coefficient, which is 2, times partial pressure of carbon monoxide raised to the power its stoichiometric coefficient, which is 1. So don't need to write down. So I can see that option C is the correct response. Let's look at question number 13, which says 4 grams of powdered calcium carbonate whose molecular mass is 100 are added to 100 centimeter cube of 0.1 moles per decimeter cube of HCl. And this is the data that has been collected. And the option says which row is of the table is correct. So first column says why the rate of reaction changes with time. So we know that whenever a reaction is taking place, let's say this is a container in which the reaction is taking place. These are the reactant molecules A, right? And these are the reactant molecules, let's say B. In any reaction, we know that they collide. These reactant molecules collide to form the product, right? So as the reaction proceeds, the reactants will be used up and products will be formed, right? So slowly you'll see that reactants are decreasing and products are formed, right? So with time what happens is there will be less number of reactants. As a result, the collisions will decrease. The collisions between the reactant molecules will decrease. So fewer collisions between the reactant molecules leads to change in the rate of reaction, right? So either option A or B can be the correct ones. Let's look at the second part of this question. Second part in second column. Why the reaction stops? The reaction must have stopped because one of the reacting species might have been consumed, right? Completely consumed. That means that one is the limiting reagent. So let's see which one is the limiting reagent. For that we can calculate the number of moles, right? So the question says 4 gram of powdered calcium carbonate. Calcium carbonate is nothing but CaCO3. It reacts with HCl to give CaCl2 plus H2O plus CO2, right? You want to balance, you can balance it 2HCl. Okay, now what is the number of moles of calcium carbonate? Number of moles of this one will be mass upon molar mass, 4 upon 100, which is 0.04, and number of moles of HCl will be equal to concentration times volume. Concentration is 0.1 times volume is 100 centimeter cube. So 100 centimeter cube you'll convert it into decimeter cube by dividing by 1000. So it is 0.1 times 0.1, which gives 0.01, right? Now these are the number of moles of reacting species. From the stoichiometry, we can see that 1 mole of calcium carbonate reacts with 2 moles of HCl. That means 0.4 mole will need 0.04 mole will need 0.08 moles of this one, but we don't have that many moles of HCl. We have only 0.01 mole. That means HCl is the limiting reagent. This one is the limiting reagent, so it will be used up, right? So the correct answer is the hydrochloric acid is used up. B is the correct answer. Question number 14 says which statement about ideal gas is correct, right? The kinetic theory of gases says that ideal gases have zero particle volume, right? We don't consider the volume of the particles in a reaction. We consider that it has a zero particle volume and there is no intermolecular forces of attraction between these particles. So C should be the correct option. Let's look at question number 15, which says a mixture of gases contains 12 gram of hydrogen, 42 gram of nitrogen and 4 gram of helium. What is the mole fraction of hydrogen in this mixture? We know that mole fraction of one of the species like hydrogen can be calculated by number of moles of hydrogen divided by total number of moles, right? Total number of moles, that means number of moles of hydrogen plus number of moles of nitrogen plus number of moles of helium. So we need to find out the number of moles of each of these species. Number of moles of hydrogen, let's find out this one. We know that number of moles is equal to mass upon molar mass. Mass upon molar mass. Mass of hydrogen is given is 12 grams and molar mass of hydrogen gas will be 2, so it is equal to 6. Similarly, number of moles of nitrogen will be mass upon molar mass. Mass is 42 grams and molar mass is 28, so you will get 1.5 moles. And number of moles of helium, mass, the given mass is 4 grams and the molar mass is also 4, so it will be 1. Let's put these values in this equation. Number of moles of hydrogen is 6 upon 6 plus 1.5 plus 1, which gives you 6 upon 8.5, and it comes out to be approximately 0.71. So option C should be the correct answer. Thank you everyone for watching this video. Please hit the subscribe button, like, share and comment. I will see you in the next video.